I'm going to add in a fault, breaking this rock in half. The block of rock above the fault plane is referred to as the hanging wall, while the block of rock below the fault plane is referred to as the footwall. Here's the fault plane. If you said this side, you were correct. That makes relative to the bottom of the block. Geologists describe this plane using two terms. We use the term standing on top of this rock and poured out a bottle of water. Which direction would that water flow? That direction is referred to as the dip direction. The angle between the fault plane and the horizontal bottom of the block is referred to as the dip angle. If I apply pressure from several different directions. First, I'll place my hands parallel to the strike and push them together. We call this compressional stress. The hanging wall in my right hand has now moved up relative to the footwall. We call this a reverse dip-slip fault. If instead I pick up the block and pull my hands apart, modeling tensional stress, the hanging wall moves down relative to the footwall. This results in a normal dip. If the hanging wall moves up relative, here is an example of each of the types of fault. Basaltic magma has a low silica content and a high magma temperature, resulting in low viscosity. Rhyolitic lava has a high silica content and low magma temperature, resulting in a high viscosity. Andesitic magma is considered intermediate on all three counts. A good general rule is the more viscape, resulting in caldera eruptions. Based on the features you see here, while looking at these pictures, try to recall what combination of silica and gas used to describe igneous rocks, the texture or grain size. Volcanic rocks that form from magma cooling quickly at or near the Earth's surface have a fine-grained or aphanitic texture, whereas plutonic rocks that form from magma cooling slowly at depth have a coarse-grained or pheneritic texture.